All right, 7.4, we have a lot to talk about in this section, applying properties of similar triangles. So we're talking about 4 theorems today, and we're going to use properties of similar triangles to find segment lengths, and then we're going to apply a proportionality and triangle angle bisector theorem. So something we need to review is angle angle. Remember, angle angle proves triangles are similar, and similar again means same shape, not necessarily the same size. And so basically angle angle is really cool. It tells us as long as we know 2 angles are congruent in 2 different sets of triangles, then those triangles will always be the same shape. Those triangles will be similar. So let's see. If I take this line and it's parallel to this base, and I cut this triangle anywhere, what happens is, because these lines are parallel, we're going to have corresponding angles that are congruent. So this angle will be congruent to this angle. Also, this corresponding angle will be congruent to this corresponding angle, and they both share this vertex angle at the top. So because of this parallel line and these congruent angles, these triangles will always be similar. There's a theorem that says also that these sides will be cut proportionally. So for example, if this one was 8 and this one was 4, and this one was 6, this one would have to be 3. And that theorem is called the triangle proportionality theorem. So basically it says if the line is parallel to another side, so if you have a triangle and a line is parallel to the opposite side, then those sides are going to be proportional. So these sides are going to be proportional. So if I put A, B, C, D, E, so how I could write that, so then AB over BC will be proportional to AE over ED. And again, how you write these proportions, it can change if you want it. If you wanted it to write it as AB over AE equals BC over ED, that also works. So as long as you're pulling from the same corresponding parts. So how can we use the triangle proportionality theorem? Let's say I wanted you to find US. So this is different. This is similar to what we've been doing before. Previously, I wanted you to find the whole side length RS, and that's where it had to get messy, and we'd have to say that side. If we wanted to find RS, for example, the whole side length, then you guys had to say, okay, 14 over 10 equals 14 plus x over 10 plus 4, and compare this tiny triangle to the big triangle. Well, if I don't want to find the whole thing, if I don't want to mess with these yucky binomials, if I just want to find US, I could say, because of the triangle proportionality theorem, well, 14 over x equals 10 over 4. So I'm looking at one side and then comparing it to the other side. And then just cross multiplying and solving. So 14 times 4 will equal 10x. And then I don't know what 14 times 4 is. I think it's 96. I could be wrong. And then divide and you get 9.6. Okay, so that's triangle proportionality theorem. The converse, remember, the converse is when you just flip it. So converse, you just flip it. So this time, if you have something that looks like parallel lines, but you're not necessarily sure, and you have something like 3 over 6 and 4 over 8, so if the sides are proportional, then those lines are going to be parallel. Let's call this AB and CD. Then we can determine that AB is parallel to CD. Okay, so again, we're going to use and this is another converse. This is the 5th converse we've learned, I think, that proves lines are parallel. So this, again, proves lines are parallel, and I would add this onto your cheat sheet, your yellow cheat sheet. All right, so again, if two sides, if this line divides the triangle proportionally, then it is parallel to that third side. Okay, so if they give you a question to verify, that means prove, show me that line DE is parallel to BC, all you have to do is show that these sides are proportional. So if I wanted to look at this side and compare it to this side, I could say 10 over 15 equals 8 over 12. Again, this isn't the only way you can write a proportion. You could also compare these two to these two. So you could say 10 over 8 equals 15 over 12. It's really however you see it. As long as you're going in that same direction, that same pattern, it should work. Because in both of these, when you cross multiply, you're going to have 10 times 12 and 8 times 15 on one side. And same over here. Again, it's just 10 times 12 and 15 times 8. So when you cross multiply, you're still getting the same thing. And so you have 120 equals 120. So you just showed, therefore, that DE is parallel to BC, just by showing that you have proportional sides. And that's all. So we've talked about two theorems, the proportionality theorem and triangle proportionality theorem, and the converse. And the second one is called the two transversal proportionality theorem. And that's kind of a lot to say. But remember, we have parallel lines. And then the transversal is just those lines that intersect the parallel lines. So these red ones are going to be our transversals. If we have 3 or more parallel lines and we have 2 transversals, what's going to happen is they're going to be cut proportionally. So if I label this A, B, C, this is point C, this is point D, this is point E, and this is point F. That was point A. What's going to happen is that side length AB over, let's say, FE will be, so these two sides are going to be proportional to these two sides, BC over ED. Or you could say AB over BC is going to be proportional to this side, FE over ED. Again, we're not saying that they're congruent, we're saying that they're proportional, they're similar. Okay, so how can that help us? Let's say I want to find LM. Again, this is just part, so I want to find out how long is this side. And we're using perspective, so we have parallel trees, and then the horizon lines are the transversal lines. Okay, so here are 2 transversals, and since these trees are parallel, we know that these pieces are going to be proportional. So I know I'm going to read this way, and then I'm going to read this way, and you can do it differently if you want to. So I'm going to say 2.4 over 1.4 equals 2.6 is this piece over side length LM, and then I can cross multiply and solve. Again, that's not the only way to do it. That is just one way to do it. And they're going to be more complex, of course. Yay. Okay, the last theorem is called the triangle angle bisector theorem, and that's, again, kind of hard to say, but we break it apart. Okay, triangle, we know what a triangle is. We've been talking about them for a couple months now. Angle bisector, remember, is something that cuts an angle into 2 congruent pieces. So the triangle angle bisector theorem says if we have a triangle and we have an angle bisector, what's going to happen is the pieces of the triangle are going to be proportional. So for example, they say BD over DC, so it's going to be proportional to the sides that are not cut in half. So let's say this is 4 and this is 8. Okay, these are being doubled, and then this one was 3, so this one would have to be 6. So, and if you fill in your blank, you could do it 4 over 8 equals 3 over 6, yes, or you could do 3 over 4 equals 6 over 8, because this also reduces down. So you could write your proportions this way, or you could write your proportions as AB to BD equals AC to DC. And we did this on Con a little bit. Okay, so this is where we can get a little bit more complex. Again, you're just kind of seeing the pattern of the different corresponding sides. So this one, let's find PS and SR. I'm just going to do one for now. I'm just going to do PS. Okay, so PS is this part. This is what I want to find. Let's see, and I have my angle bisector here, so I know that these pieces are going to be proportional, not congruent, proportional. So how I look at it is 2 different triangles, and I say, okay, this 32 looks like this 40 from this other triangle. And then I have to go back to this first triangle again. So the other side length is x minus 2. That's similar to this side length from the second triangle, x plus 5. And then I'm going to have to cross multiply and solve. And if you want to reduce this, simplify this, and make it easier numbers, let's see, I think we can divide both by 8, right? So then I'd get 4 over 5 equals x minus 2 over x plus 5, and that just helps me out a little bit with my math. And then I cross multiply. Remember to distribute x minus 2. Okay, so I'm going to have to distribute. So 4 times x is 4x, 4 times 5 is 20, 5 times x is 5x, and 5 times negative 2 is negative 10, and then I'm just going to have to move everything and solve for x. So I've subtracted 4x, I get x, add a 10, and I get x equals 30. And I'm done with that problem. So we learned a lot of theorems today. We learned 4, and we're going to talk tomorrow or someday soon about how we can use these theorems for perspective drawings. Fun times. And fun fact of the video, one man dribbled a basketball for 230 miles to raise money for Japanese tsunami victims. That is really incredible. 230 miles is pretty much like dribbling down from here, from school to San Diego, and then back, and then maybe even a little bit more. Pretty impressive. All right, we are completely done with similar triangles and congruent triangles, and you guys are amazing.